Today's video is about finding the equations of altitudes, medians, and perpendicular bisectors. We're going to start with an example about a triangle, and the triangle we're going to look at is triangle PQR, and it's called triangle PQR because the three vertices in the coordinate plane are at P, Q, and R. And we can see what those coordinates are. P is 1, 9, Q is 3, 5, R is 5, 7. And the first question we want to ask is we want to find the median QM. That means I want to find the median that starts at Q and goes to the midpoint of PR. That's the same as saying find the median from Q. So I want to find the equation that goes from here, Q, to this midpoint on the segment PR. So what we're going to do first is step number 1 is to find the midpoint. Find that midpoint on the line segment PR. So we know the formula. The formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And we're going to have to use the x's and y's for P and R. So here's P, here's R. We're going to use those two coordinates and find the midpoint between those two coordinates. So I have 1 plus 5 divided by 2, and I have 9 plus 7 divided by 2, and that means I've got 6 divided by 2, and I've got 16 divided by 2, which means this midpoint right here is the point 3, 8. Right here, 3, 8. And I want to find the median from Q. The median goes from Q to the midpoint of PR. So let's remind ourselves that Q has the coordinate 3, 5. And I want to find the equation of the line between Q, and we'll call this M for midpoint. That's why in the question initially it said find the median QM. We want to go from Q to M. So I'm going to use my equation in slope y-intercept form. I need to find the slope. Step number 1, find the slope. So first I found the midpoint. Number 2, I'm going to find the slope of the median between Q and M. So I'm going to make a little table here. I want to go from 3, 5 to 3, 8. This right here is 3, and this right here is 0. And oh my goodness, I can't possibly do that slope because 3 divided by 0 gives me undefined. And the reason it's undefined is because, if I were to graph this, 3, 5, and put it in a coordinate system, 3, 5 is right here, and 3, 8 is right here. I have 3, 5 is Q, and I have M being 3, 8. This, I can't find the slope of that because it's totally vertical. That is just the vertical line that goes through x is equal to 3. So if I want to find the equation of this line, it would be x is equal to 3. Now, if I would have gotten a nicer answer for my slope, then I would have put that nice answer into my M, and then I would have picked either x or y, doesn't matter which one you pick, to put here, and then you would find your B. But this is a special case where Q is at 3, 5, M is at 3, 8, and that means it's a vertical line going through x is equal to 3, so the equation of the median this time is simply x is equal to 3. For our second example, we want to find the altitude of triangle EFG, where E is negative 4, 3, F is 6, 3, and G is 2, 11. So we want to find the altitude. What does altitude mean? Here is a picture of triangle ABC, And we can see that the altitude is simply the height of the triangle. So in this example that we're going to do right now, we want to find the height of triangle EFG. Now this is actually a special triangle, and because it's special, it makes finding the altitude easier than it normally is. So for today's lesson, we're only going to look at triangles where the base is perfectly horizontal. And we can see that this base is horizontal because E is at -4, 3, and F is at 6, 3. The Y is not changing. The Y is 3 for both of those points. So that means the base is horizontal, which means finding the altitude is significantly easier. So if I want to find the altitude, I first am going to have to find the slope of the base. And the reason I need to find the slope of the base is because we know that the altitude or the height is at a 90 to the base. There's a 90 angle right there. So let's find the slope of the base right now using the formula for slope, which is m is equal to y2 minus y1 over x2 minus x1. Or if you like, you can make a little table and subtract, and then divide. I have found the slope. The slope of the base is going to be 0 over 10. And that makes perfect sense because this base is perfectly horizontal. It's not going up at all. It's going straight across. It's going from height of 3 here to a height of 3 over here. The y's are not changing, which means the slope is 0 over 10. That makes sense. Now, if I want to find the equation of the altitude, I know the altitude is at a 90 to this. 90 degrees means that the slope should be the negative reciprocal. But does that work in this example? Because in this example, if I take the negative reciprocal, I would have -10 divided by 0. If you try that with your calculator, what do you get when you do -10 divided by 0? You get something that is undefined. It's an error message on your calculator. So this is not possible. So this is another example, like the one we looked at the beginning, where my altitude is perfectly vertical. So let's look at this in Desmos to show you what I mean. I'm now showing you in Desmos. I plotted the 3 points for a triangle EFQ, and you can see that this is a special triangle because those 2 points along the base are perfectly horizontal. They're in a horizontal line. They're both at y value equals to 3. So that makes this a special triangle. The next thing we can see is that if I want to know the equation of the base is just that line that goes through y is equal to 3. It's perfectly horizontal. So if I want to know the altitude has to be the opposite direction of y is equal to 3, and instead of being perfectly horizontal, it's going to be perfectly vertical. So it's going to be this line that's perfectly vertical going through x is equal to 2. So the equation for the altitude of this triangle is x is equal to 2. If I come back to my table on my chart paper, I see that that makes sense. I've got this line that's perfectly vertical. And if this were on a Cartesian plane, if I were to have graph paper, here would be 0, and this point right here would be 2. And it makes sense that it's 2 because this point right here is 2, 11. So this altitude has equation x is equal to 2. For our last example, we're going to look at this question where we're asked to find the equation of the perpendicular bisector of side AB. So we know that if it bisects AB, it needs to cut AB in half, which means I would need to find the midpoint of AB. So let's do that first. Let's find the midpoint of AB. So press pause in the video, use the midpoint formula, and find the midpoint of AB. Okay, so we found the midpoint of AB, and we know that the midpoint using that formula is 0, 2. Right there is the midpoint. and we want to find the perpendicular bisector of side AB. So I have bisected side AB. That means split it in half, and I do that with the midpoint. And now I want the perpendicular bisector. That means that I want the equation of a line that bisects, that goes through this point, that bisects AB, but that is perpendicular to AB. I want to find a line that is perpendicular to line segment AB. If I want to find something that's perpendicular to AB, I first need to find the direction or the slope of AB. So let's find the slope of AB right now. I've taken the coordinates for A and B. I put them in a table of values. -2 to 6, I'm going up 8. 2 to -2, I'm going down 4. So this means that the slope is 8 over -4, and that's the same thing as 2 over -1. So if I want to find something that's perpendicular to AB, the slope can't be the same. The slope needs to be the negative reciprocal. So instead of being negative, it's going to be positive. And instead of being 2 over 1, it's going to be 1 over 2. That means this perpendicular bisector has slope 1 over 2. So our job was to find the perpendicular bisector. We had to bisect AB, so we had to find the midpoint. We did that first. We needed our perpendicular bisector to be perpendicular to BA, so we found the slope of BA. And then since our perpendicular bisector was perpendicular, the slope has to be the negative reciprocal. So last step is I want to find the equation of the line with slope 1 over 2 and going through this midpoint that bisects AB. So I want to write down y is equal to mx plus b. I know my slope is positive 1 over 2. I'm going to use my 0 and my 2 to find my b. So I have 2, 1/2, 0 plus b. This just gives me 0. So that means my b is equal to 2. That means the equation of this line is y is equal to 1/2 x plus 2. And that's how you find the perpendicular bisector.